So how can we tell if we have a right inverse of that? Because if we know it's a right triangle, well, we don't know it's a right triangle. We know if it is going to be a right triangle, we'd have to square the legs and add them together and see if we get the square of the hypotenuse. So in number one, if we want to test this out, which side would have to be the hypotenuse? The longest side would have to be the hypotenuse. We're going to take the other two, which would be the legs, 3 squared plus 4 squared. We want to see if that's equal to 5 squared. We don't know, so this is what we're testing out. So 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. When we add these two, we do get 25 equals 25. So yes, this is a right triangle. So that is what you would do to test it. Okay, what if we dilated the triangle in number one by a scale factor of 3? So we're using some of our transformations here, see if you know what the word dilated means. So if the previous one was 3, 4, and 5 were the sides, and we want to dilate it by a scale factor of 3, what would we need to do? We would need to multiply each side by 3, giving us 9, 12, and 15. So we want to see if these could be sides of a right triangle. So we're going to square 9, we're going to square 12, so 9 times 9 is 81, 12 times 12 is 144. Add those together, and you get 225. We want to see if that is what 15 squared is, and you can use your calculator to do that. Yes, you get 225, so yes, they are equal. So yes, it is a right triangle. So when we dilated it by a scale factor of 3, it worked. What if we dilated the original triangle by a scale factor of 1/2? Well, again, our original numbers were 3, 4, and 5. So if we multiply 1/2 or divide by 2, we're going to get 1.5. Here, if we divide by 2, we're going to get 2. And here, if we divide by 2, we're going to get 2.5. So if we square these, 1.5 squared, you're going to get 2.25. 2 squared would be 4. And that gives us 6.25. So if we square 2.5, we do get 6.25. So again, it would be yes, these two are equal. So what conclusion could we make about dilations of Pythagorean triples? So if you dilate the original triple, and it is a Pythagorean triple, so maybe Pythagorean triple, it will still be a triple, Pythagorean triple. So as long as you start with something that is right sides of a triangle, if you use a scale factor on it, it will continue to work. All right, are these Pythagorean triples? Well, again, we would need to take and we need to square the sides, the legs, and see if it's a hypotenuse. So 7 squared plus 24 squared, does it equal 25 squared? And again, use your calculator for the harder ones. 24 squared is 576. You add those together, you get 625, and 25 squared is 625. So yes, these would work. 8 squared plus 12 squared, does it equal 16 squared? So 8 squared is 64 plus 144. If you add those together, you're going to get, what, 208, I think, and 16 squared is 256. So this would be an example of a no.